Very good morning. Am I audible, students? Vaishnavi, Daitva? Okay. Daitva, you are from Nagpur, right?
Ma'am.
Yes?
Yes, ma'am.
Okay. Do visit the science exhibition at VNIT.
Yes, ma'am, surely.
There are so many working models in the science exhibition with belt drives, chain drives, flywheels, gears, all kind of gear drives and the gearbox assemblies, everything shown in the section view and the working models. I really was looking forward to have all MD2 students for this exhibition. Better late than never. All of you got the notice, right? You will be coming to the campus on 21st of March. So at least we'll have few classes in the physical mode. That is really good. Well, let's start. What do you understand by the term flywheel? What is a flywheel? And why do you need a flywheel? Just one? Just one? Are you there? Just one is not there. Yeah, just one. What do you mean by a flywheel? Who is roll number 23? No name over there. BT 1923. Yeah, flywheel is a device which stores energy. And where do we use a flywheel? Who is roll number 23? Punching machines. Yes. Which machines, Kajal? Venkat Sai. Attached to the rotating shaft. Okay. Why do you need a flywheel? Why do you need a flywheel in any engine or in a machine? Nipun, because power production is not uniform. Yes, to match energy requirements. Correct. What else you know about flywheel? I guess you have studied this in Theory of machines 2 for balancing. Power from motor to machine. Ayush, how this helps in balancing? Ayush, absorb excessive energy. Okay, this is correct. How this helps in balancing? It has very high moment of inertia, yes. To avoid fluctuations. Correct. Fluctuation of what, Anshuman? Anshuman, fluctuation of speed, yes. And fluctuation of speed and fluctuation of torque. Yeah, so ideally it is to take into account the fluctuation of torque, and while it is absorbing or releasing energy, the speed of the flywheel that varies. Okay, so let's start with the discussion of flywheel. You know the basics about flywheel, so it will be easier for us to start designing the flywheel. You see, this is a crankshaft. These are the connecting rods, piston, and here you can see these are the cams. And here this is a flywheel. So flywheel is normally a rotary disc attached to one end of the shaft. It can be a crankshaft or it could be a line shaft, or depending upon which kind of machinery we are using. We have a heavy mass rotating disc which is known as flywheel. And this is an essential part of machine because this takes into account the variation in the torque. Whenever there is the variation in the torque or the load, the external load variation or the torque variation, flywheel comes into picture. So not all operations would be a kind where the torque is varying or the load is varying. But then there are few applications or few operations where the torque is continuously varying. So within one particular cycle, there is a maximum torque required, and for the remaining strokes, the torque required might be less. And for such kind of variation, we want that the operation should be smooth. So a flywheel will ensure a smooth operation. Flywheel will also ensure that we are managing or we are working with a smaller rating driving motor. The driving motor or the prime mover is my screen visible to all of you? Utkarsh? Ayush?
Yes, ma'am.
Tiwari sir, why it is not visible to you?
I rejoined, ma'am. I think some problem
Okay.
with the connection or something.
Yeah.
Thank you.
The driving motor that we are using, this could be a small capacity driving motor with a lower power rating. And why this? I'm coming to it. So the normal torque requirement is low, only at the peak hours the torque required is very high, and we don't have to use a motor which is supplying the maximum required power or the torque. Since we have this flywheel, which is an energy storing device, this can take into account the peak requirements or the peak demand. We don't have to use a motor which is supplying the peak energy. we can still work with a motor supplying an average demand or taking care of the average demand, and the excess torque required or that speed requirement, this can be fulfilled with this flywheel, which we also call as energy storage device. So as you can see, this is the flywheel attached to one end of the shaft. If the requirement of the torque is high for an operation where high torque is required, we'll come to its application. If the torque requirement is high, the energy from the flywheel, this is supplied. Flywheel will supply energy. What will happen to the speed of flywheel? The speed of the flywheel decreases. And when there is a low torque requirement, the flywheel will store energy, and while storing this energy, the speed of the flywheel increases. Good. This is how it takes care of the variation of the torque. If it is like an electric generator which is continuously supplying torque at a uniform RPM, and it is driven by a turbine which is again rotating with constant RPM, continuously supplying a constant torque. So if the input and output both are working with uniform speed and the torque requirement is throughout is constant, in such kind of application a flywheel is not required. But for an application like an IC engine, so this is a 4-stroke IC engine, and you have these 4 strokes: suction stroke, compression. This is the expansion or the power stroke, and then there's an exhaust stroke. So for suction, compression and exhaust, the torque required is, we are looking at the magnitude, is minimum. And in the power stroke, there is a huge torque, lot of energy that is created, or it is a power stroke. So this is producing power for driving your motor wheel or the vehicle. So here this is the maximum torque, and this is the minimum value of torque. So somewhere around here, this is the mean torque. So we are working with mean torque value, and this is the excess amount of energy which is produced, and this gets stored in the flywheel. So whenever there's an IC engine application, because the power supply, this is the prime mover. IC engine is generating power, it is supplying power. So within a cycle, the amount of power that is generated, this is varying. So small power, here it is consuming power. Work is done on the wheel or on the engine. Here the work is done by the engine. Again, the work is done on the engine. So in this particular stroke, the power is generated, which means within the cycle, the power that the IC engine is supplying is not constant, and hence a flywheel is required here. But if we talk about an electric motor where the electrical energy is converted into mechanical energy, we know that power supply is constant. So at the input stage, it is always constant. So IC engine as an input source of power. This as a prime mover or an input will always need a flywheel if this is on the input side, and if the input is an electric motor, then a flywheel may or may not be required, because this is continuously supplying constant torque. Now it also depends upon what is the application. Now, application might be an application where the load is continuously varying. So, if the application requires variation in torque, then the input machine component which is supplying power uniformly, this is not continuously consumed, and hence there is a variation which needs to be stored in the flywheel. So, this variation of energy is stored in the flywheel. In that case, a flywheel might be required. So if the input and output both are rotating or both are running at constant load, constant torque, a flywheel is not required. But if any one of them, either at the input end or at the output end, there is a variation of the load, then a flywheel is required. On the application side, it's a punching press application which requires a flywheel. So as you understand, in a punching press, this is a crank which is continuously rotating around this shaft, and this is the plate where a hole needs to be punched. So while this is rotating from this part to this part, so for 3/4 of the rotation there is no load, and for 1/4 of rotation, when this has to punch a hole, when this tool has to cut and shear this plate, this requires a very high amount of torque. And for this torque requirement, the energy required is high, and for the remaining 3/4, when it has to move back, go back, and this is rotating, the power required is less. Now this is on the application side where a large amount of torque is required, and hence a flywheel is normally mounted on this shaft. This is the crankshaft. If you see the side view, this will be the crankshaft. The crank is rotating here. This is the connecting rod. This is the punching tool. And on the extension of this shaft, you have a flywheel. So this is the basics of flywheel. We'll see how do we get the formula for energy stored in the flywheel. For a flywheel which is continuously rotating, by the basic formula, the kinetic energy is given by half I omega square, where I is the mass moment of inertia and omega is the RPM with which it is rotating. Now this value of omega, this keeps on changing, and this varies from a value of omega 1, if this is maximum, to omega 2, or omega max to omega minimum. So it is continuously varying from omega 1 to omega 2. So during this variation, the amount of energy that gets stored in the flywheel, or the amount of energy which is released from the flywheel. Depending upon the requirement of the torque, if the excess power is generated, the energy is stored in the flywheel. If more torque is required, then the energy is released from the flywheel. And this energy stored or released, this would be I omega if I'm using 1 minus half I omega 2 square. So the released or the stored energy, this is difference between the kinetic energy initially and the kinetic energy finally. Either it is rotating at this RPM, excess amount of power is generated which gets stored. So this difference is the energy stored or the energy released, which I am rewriting as omega 1 square minus omega 2 square. Expanding this, say the mean value, omega mean, is the average of these two velocities, omega 1 plus omega 2 by 2. If I multiply and divide this with omega mean, then I get the expression as omega 1 plus omega 2 by 2, this is omega mean, into this omega mean. So I am writing this as half I omega m square, this omega 1 plus omega 2 by 2 and this omega m. So this is making square. And this omega 1 minus omega 2 by omega m, difference between their angular speeds upon their mean speed. This is given by a term Ks, where Ks stands for coefficient of fluctuation of speed. This half is gone. This is the formula for energy stored or energy released, del E. I omega m square Ks, where the formula for Ks or the value for Ks is normally given in the design data book, depending upon for which application we are using. I omega m square Ks, so I is the mass moment of inertia, omega m is the mean velocity, the mean speed, which is omega 1 plus omega by 2, and Ks is the coefficient of fluctuation of speed. So it is this formula which we'll be using. Now there are different types of flywheels. This is a solid flywheel. This is a web type of flywheel where the thickness at the rim is more than the thickness at the remaining body of the flywheel. A disc type flywheel is when the thickness is same throughout. And then you have this rimmed flywheel. So depending upon diameters, when do you have a rim flywheel and when do you have a solid flywheel? Yes. How do you decide when do you go for a rimmed or an armed flywheel or a solid flywheel, depending upon the diameter? Yes. So for larger diameter, we go for the rim flywheel. So this is exactly same as the pulley design or the gear blank design. So depending upon diameter, we decide whether we are going for a solid disc web type or rimmed or arm type. Similarly, number of arms will also depend upon what is the diameter, what is the RPM. So a solid construction would be always easier. If we go for a rimmed type flywheel, this is the height of the rim. The maximum amount of mass of this flywheel is concentrated at the rim, and almost 90% of the mass of entire flywheel is concentrated at the rim. So only 10% is at arms. So we want the mass to be concentrated more away from its center. So if this cross section is say this is the rectangular cross section for the rim having its width b and this height is h, this height is h. We are using this as h. And if d is the diameter, let me use this term as d mean, dm. We'll call this as the outer diameter, which will be d mean plus height, and this is the inner diameter, which is d mean minus height. So it is minus h by 2 minus h by 2. So the mass moment of inertia, as you know, is I is m into r square or k square, radius of gyration, and for a circular wheel, this becomes mr square, which is m mean radius is mean diameter by 2 whole square, and the mass will be taken in terms of density into its volume into its radius square. Normally the material used for flywheel is what? Which material is used for flywheel? Saurabh? Same as the material used for the pulley. Yes, usually cast iron, sometimes cast steel, but usually cast iron, so we'll be taking the density of cast iron. Talking about the volume, this cross section is B by H, and here it is this periphery pi dm, the circumference. So its volume is pi dm into B into H into dm by 2 whole square. This is how we are going to find out what is its mass moment of inertia. BH by 4. And this ratio for B by H, this is given in the data book. This varies from a value of 0.65 to 2. So we are free to choose a value. We'll normally go with 1, 1.1, 1.2 as B by H. So while solving the numericals, we'll calculate what is the energy fluctuation. We'll know the mean speed that would be normally given. We have to calculate what is I. From this I, we have to design a flywheel. So designing a flywheel essentially is getting its dimensions. A designing of whatever we are designing, when we are designing a belt drive, we are getting the cross section of the belt, number of belts. When we are designing a gear, we are finding its module, we are finding its face width. Likewise, for designing a flywheel, we have to get these dimensions. So we have to get the value of dm, b and h, for which we have to get the value of I. And for getting the I, we'll see for a given application what is the energy fluctuation. From the energy fluctuation del E and the formula that we discussed just now, the variation in the energy is I omega n square Ks. Ks will be given in the data book, coefficient of fluctuations of speed. Omega m will be given in the problem statement. We have to find out what is I. And from I, knowing the material or assuming the material density would be known, we have to get dm, b and h. For b by h, this would be the ratio. Let's talk about the centrifugal force. Now this is rotating at a high speed and you have large mass concentrated at its rim or at its periphery. So let's talk about the centrifugal stress and the centrifugal force here. Please draw this figure. I'm taking a small section of the flywheel, assuming this to be small. Let this angle be del theta. So in an exaggerated view, as you can see, the centrifugal force is acting away from the center with this value as FCC. This is H. And its cross section is B. This is B. This is B and this is H. Here this is the mean radius or the mean diameter. RM or dm by 2. Mean radius. Here there would be normal reaction perpendicular to this surface. What would be this angle? If this angle is del theta, this angle will be half of del theta. On the either side, acting at this angle. This is the normal force. So what is the magnitude of the centrifugal force? If the mass of the rotating object is m, which is rotating at a linear velocity v, what is the centrifugal force acting at its radius r? Ujjwal? mv square by r. So this centrifugal force this is given by mv square by r. Here it is rm. Let me write it down here. So this mass is again density rho into its volume. So length of this arc for this small section is given by what? If radius is rm and this angle is del theta, what is the volume for this particular sector? Harshil? Rm del theta, length of the arc, into its cross section B h, its linear velocity v square by rm. Is that correct? Mass is density into volume, and volume is this length of the arc into its cross section b h. And these are the two normal reactions N acting at angle del theta by 2. Their cos components, they are cancelling each other. N cos del theta by 2 minus N cos del theta by 2. This is 0. They are acting in opposite direction. What about their sine components? The sine component will be equal to the vertical component Fc acting outwards and the vertical component, that is the cos component, this will be N sine del theta by 2 plus n sine del theta by 2. So the normal reaction. This is 2n sine del theta by 2. So this is from the standard formula and this is from the force balance equation. So if I equate 1 with 2, simplify this and give me the expression. As you understand, we always simplify. For small value of del theta, sine del theta is equal to del theta. And so I am also writing the same expression as 2n del theta by 2, or this is simply n del theta for small value of theta. Sine theta is assumed to be equal to theta. So what do I get? Rho Rm del theta p h v square by Rm, which will get cancelled, is equal to n del theta. So this del theta gets cancelled, this Rn gets cancelled. So you are finally left with rho v square is equal to n by ph. What is n by bh? N is the normal force which is acting on a surface whose cross section is b by h. So what is this force by area? This is the stress. And do you know what is this stress? Because of the centrifugal force which is acting radially outwards, what is the direction of centrifugal stress? Can you tell me? Can you tell me what is the direction of centrifugal stress? Yes, it is this stress. This is the direction of centrifugal stress. It is always perpendicular to the cross section. So this is the stress which is induced because of the centrifugal force. So this is another question for your interview. If the centrifugal force, if an object is rotating, the centrifugal force is always acting radially outward. What is the direction of centrifugal stress? So it's because of this particular force that it is trying to shear off the entire rotating object into number of small pieces. So while shearing off, this is shearing away from this section, which means the entire stress is acting along this surface. So the stress is always perpendicular to its cross section. And this is the normal stress or the centrifugal stress. So this N by BH, this happens to be centrifugal stress. Or the normal stress. So this is the stress which is induced because of centrifugal force. So this rho v square is centrifugal stress or N by BH is centrifugal stress. And it is always acting perpendicular to the cross section of the flywheel, cross section of the flywheel rim. So before we start solving the problem, the most efficient flywheel design when you are designing a flywheel for design or for an optimum design, we want the value of I to be maximum. The value of I depends upon M and R. So to increase the moment of inertia, either you have to increase the mass or you have to increase its radius. So which one is better? To increase M or to increase R? To increase R. If you increase the mass, only the mass, then the weight increases and the cost increases and the amount of material that is required that increases. But if you increase the value of R, then since I is proportional to square of R, it's always better to increase R and reduce M. So we'll always try to maximize the value of R. Moment of inertia increases. With the increase in R, moment of inertia increases by square of R, and this is not increasing the weight and hence it is not increasing the cost. But you cannot increase the value of R to a very high value because then space becomes a constraint. So the maximum value of R, this depends upon what is the space available. So there has to be an optimum value always. You cannot go on increasing radius or mass to any limit just because you want to increase the moment of inertia. And the material, this mass would depend upon its density, and the density would depend upon the kind of material that we are choosing, and hence cast iron or cast steel. These are the most preferred material because this will offer high density. These are the preferred materials for cast iron. I'll give you the problem statement. Maybe we can solve this in the next class. So all the problems of flywheel would be of two types. Either it would be a punching press operation, which is on the application side, driven by an electric motor, or it would be an IC engine based flywheel, which means the variation is there at the input side and the output may or may not have any variation in the torque. So the problems would be either IC engine based or it would be punching machine based. Just write down the problem. We may not be in a position to solve in 10 minutes, but okay, at least we'll start in the next class. A punching press produces produces 25 holes per minute in a steel plate of 20 mm thickness. If the maximum diameter of the hole to be punched is again 20 mm. Diameter of the hole 20 mm, thickness of the plate 20 mm. And the ultimate shear strength is given as 350 MPu. Ultimate shear strength is given as 350 MPa. If the actual punching operation, takes place in 1/8 of total cycle time. 1/8 of total cycle time. You see, 7/8 of the cycle time. The energy is stored in only 1/8 of the cycle time. The energy is released from the flywheel. Find the energy to be stored in the flywheel per cycle. Find the energy to be stored in every cycle of the rotation. Additionally, if the flywheel is connected to the crankshaft, on which the punch is located. So punch is on the crankshaft. So the flywheel shaft is connected to the crankshaft using spur gear pair. With a velocity ratio of 10:1. Design a suitable flywheel. Design a suitable flywheel. So we are not solving it now. We'll start solving this problem in the next class. Can you tell me what is the RPM of the crankshaft on which this punch is mounted? RPM of crankshaft? From the problem statement, can you make out 25? It is punching 25 holes in a minute, which means it is moving in 1 minute. It is moving through the steel plate 25 times, which also means that the RPM of crankshaft is 25. So what is the RPM of flywheel shaft? RPM of flywheel shaft, 200, 250. Yes, it is 10 times. It is 10 times of the RPM of the crankshaft. So RPM of flywheel is 250. Okay, so we'll stop here for the day. Do you have any questions to ask?
Ma'am?
Yes.
Ma'am, what is the syllabus for mid-semester exam?
Up to flywheel.
Okay, ma'am.
Yeah.
And
gears complete, belt drive, chain drive complete, and flywheel.
okay, ma'am. And is this syllabus will this syllabus be in the end semester also?
Yes. End semester will have a complete syllabus. End semester would be assembly of all these machine components that we are talking about. So in a single problem, NSEM will be in offline physical mode. So 3 hours paper, you will have probably only 2 questions to solve. And both the questions will be assembly. So in a single problem, you'll be designing a flywheel, you'll be designing the shaft, bearing, a gear drive or a belt drive, or the drive also you will be selecting. So one problem will be like covering half the syllabus. Another problem will be covering the remaining half of the syllabus.
Okay, ma'am.
Okay.
Ma'am, and
Ma'am,
semester will be for 35 marks or 60 marks?
End semester.
Yes, ma'am.
I don't know. I'll confirm with Dean Academy.
ma'am, actually, Dean Acad says us that the marking system will be same. So will we get
Same.
1.5 hour or 3 hours in end semester for solving the paper? If the marking system is same, then the time system is
Time
also
should
same, right?
remain same. Yes, should remain same. How does that matter? पढ़ना तो पूरा ही है, right? Aditya?
No, ma'am, not
No.
not the issue of padna. Yeah, like most of us, the student want a surety that अगर एक बार आ गए, then वापस नहीं आना है घर पे. End semester के बाद ही आना है. So
Okay,
that
so
is
if
the
you
main
assure that there is no fourth wave coming, then we can assure that this will be definitely in offline mode, isn't it?
But ma'am, no one can give a surety for fourth
Yeah.
wave.
Right. So how can somebody give you assurance that once you are here in the campus, you will not be sent back?
And then, ma'am,
Isn't it?
then
It's not by
then
choice
some,
that you were sent
yes,
back in the month of December. It was only because the
yes,
cases were increasing and the entire city and all the press, they were behind us. It's only because of PNIT that the cases are going up.
yes, ma'am,
And
yes,
there
ma'am.
was so much turbulence in the press and in the newspaper, and I was like, we all were getting continuously calls कि आपने ऐसे कैसे students को बुला लिया. That was the reason we had to send you back. Anyway, this is off the record. Okay,
Yes,
so
ma'am.
that was for the well-being of students, isn't it?
Yes, ma'am, yes, ma'am.
Yeah,
We
we are
don't
not
have any
enjoying.
doubt
We are
on
not
that.
enjoying empty hostels and vacant classrooms.
Yes, ma'am. We are also not enjoying sitting in a room of and not getting an explorer for whatever we have to learn.
I know. I know. So taking one day at a time, we prepare for whatever is being taught in the class, and we appear for examination. I really am not sure about what is going to be the marking pattern and what will be the timing. But हमेशा जो रहता है, so end sem is for 3 hours or whatever 60 marks. वो 40 marks का assessment in online mode becomes so difficult. I only know those students who are answering in the chat box. I don't know what other students are doing. They may or may not be solving. They are not answering doesn't mean they are not solving, or if they're answering on the chat box, that even doesn't mean they are solving. वो तो एक ने आंसर पोस्ट कर दिया है तो everybody starts posting. Isn't
मैम
it?
और एक डाउट है
Yeah.
हम लोगों के सेक्शन डिवाइड हो जाएंगे क्या ऑफलाइन जाने के बाद?
Yes, because class capacity तो 60 ही है.
यस मैम एंड उसमें भी लाइक सोशल डिस्टेंसिंग एंड ऑल अगर रूल्स हो जाएंगे तो
वो
मे बी
तो सारे rules they have relaxed. As of now, it's relaxed. So social distancing तो कितना follow होगा? Once you are here in the campus, mess में तो सब साथ में बैठ के खाना खाने वाले हैं. So what is the point in maintaining social distance in the class? Isn't it?
यस मैम यस मैम.
Yeah, फिर से कॉरिडोर में आके सब खड़े होते हैं. So everybody is standing close to each other and talking and chit chatting. So classroom के अंदर social distancing है, कॉरिडोर में there is no social distancing. Abhi, look at the exhibition. Yesterday we had more than 1,000 students.
Yes, ma'am.
Yeah, no social distancing. What is social distancing? What is corona? ऐसा हो गया yesterday.
But ma'am, this is not the right way. Like, if we won't want to come for like, अगर अपन fourth wave को welcome करना नहीं चाहते तो ये सारी चीजें तो
We
follow
should
करनी.
avoid this. Right. We should avoid this. Yeah, so there are so many things on paper. Not everybody is practically applicable, isn't it?
Yes, ma'am. Yes, ma'am.
Yeah.
Ma'am, actually, one more request from our side. If possible, can we have all the labs again in the campus?
Uh,
Means
yes,
at
वो तो
least
आपको
for six
लेकिन टाइम
months or
टेबल
like.
एंड स्लॉट you'll have to see.
Yes, ma'am. Yes, ma'am.
Yeah, in a single practical, if you can conduct more than 2, 3 experiments.
Yes, ma'am.
Yeah.
Because that will be more beneficial.
You can always request whosoever is your conducting your practicals.
Yes, ma'am. Yes, ma'am.
That is
Okay.
possible.
Thank you.
Yeah. What else? Okay. So if there are no more queries, we'll stop here for the day. Thank you so much.